All right, let's take another look at a related rates problem. Example 2. Air is being pumped into a spherical balloon so that its volume increases at a rate of 100 cubic centimeters per second. How fast is the radius of the balloon increasing when the diameter is 50? Okay, let's start with what we have. We have a spherical balloon. So imagine perfect sphere. We know this is based on the radius. We know that the volume is increasing at a rate. So we know dV dt, change in volume with respect to time, is 100 cubic centimeters per second. We want to find how fast the radius, so we're trying to find the r dt when the balloon has a diameter of 50 centimeters. Now note over here we have the radius. We know that if the diameter is 50, then the radius is half of that. So we're going to account for that. The radius is 25. So what we need is a formula for the volume of a sphere. We know that the volume of a sphere is given by the formula 4/3 pi r cubed. I can write that a little bit neater. So 4/3 pi r cubed. Now, note, if you have this on the AP test, they do give away the formulas, so you don't have to have them memorized. Let's go ahead and let's find the derivative with respect to time. We know the derivative of v with respect to time is, in fact, dv dt. We know that the derivative of 4/3 pi r cubed is only going to affect the r. Pi is a constant, 4/3 is a constant, and the 3 is our power. Using the power rule, we keep the 4/3 pi, and then the r cubed has a derivative of 3r squared dr dt. We know that the 3 and the divide by 3 cancel each other. So we know that dv dt is simply 4 pi r squared dr dt. We are trying to find dr dt. So we're going to move anything except for dr dt to the other side of the equation. Note, the 4, the pi, and the r squared are all being multiplied. So we're going to move them to the other side of the equation by dividing them. So 1 over 4 pi r squared dv dt is in fact dr dt. Now, we would like to find dr dt specifically when the diameter is 50, i.e. when the radius is 25. So this is 1 over 4 pi times 25 squared times dr dt, times dv dt, which is 100 cubic centimeters. So 100. So this is 100 divided by 4, note, is 25 over, note, 25 squared is 625, 625 pi. 25 goes into 625, 25 times. So that is 1 over 25 pi, and this is centimeters per second. So the question is, how fast is the radius of the balloon increasing when the diameter is 50 centimeters? The radius of the balloon is increasing at a rate of 1 over 25 pi centimeters per second when the diameter is 50 centimeters. And done.